Welcome, everyone. I'm glad you're here today. We're about to dive into a comprehensive guide to valves in water and wastewater systems. The title of our presentation is Valves are Essential Components in Water, Wastewater, and Industrial Systems, serving as the primary control devices to start, stop, or regulate the flow of fluids. We'll explore how valves are used to isolate sections for repairs, manage system pressure, and improve operational efficiency. Over the next few slides, we'll cover the different types of valves, their functions, and best practices for their use. Let's get started. Let's take a closer look at the key differences between these two main types of valves. First, we have rotary valves. These are characterized by an internal element, like a ball, plug, or disc, that rotates through an arc, usually about 90 degrees or a quarter turn, to open, close, or partially restrict flow. This rotation makes them very efficient for controlling flow quickly and reliably. On the other hand, we have linear valves. These operate by moving a closure element, such as a gate, wedge, or globe disc, in a straight line, either up and down or in a blade-like motion. This type of movement is often used to start, stop, or regulate flow more gradually. Now, understanding these classifications, linear and rotary, is essential because each serves different operational purposes and is designed for specific applications within water and wastewater systems. Recognizing which type suits a particular need helps ensure optimal performance and longevity of the system. This is a fundamental step in selecting the right valve for the right job. Gate valves are not suitable for throttling or regulating flow. When you partially open a gate valve, the fluid tends to slap against the partially open gate, which can cause significant damage to both the valve itself and the seating surfaces. So, they are really designed for fully open or fully closed positions. One of the critical limitations to keep in mind is their primary use, mainly for isolating sections of the water main. This allows us to perform emergency repairs or maintenance without shutting down service over large areas. Because of this, they're primarily used for main line isolation, and it's important to exercise them at least once a year to ensure they function properly. Now, let's talk about their primary function. When fully open, the gate is drawn up into the bonnet, leaving an opening that's essentially the same size as the pipe itself. This design allows for a straight line flow, which means minimal flow restriction and a low pressure drop, very efficient for flow when fully open. In terms of mechanism and design, gate valves are the most common type in water distribution systems. They're almost exclusively used as shutoff or isolation valves. They operate by inserting or withdrawing a wedge-shaped gate perpendicular to the flow path, effectively blocking or allowing flow. And that's why we call gate valves the isolation workhorse. They're reliable, simple, and effective for shutting off water to sections of the system when needed. Understanding their proper application helps us maintain the integrity and efficiency of our water distribution network. Let's talk about the application of these gate valves. The first type, the rising stem or OS&Y, is commonly found on fire lines. This is because it provides a clear visual indicator of whether the valve is open or closed, which is crucial for safety and operational awareness. When the valve is opened, you'll see the stem rise out of the handwheel, making it easy to tell its status at a glance. Now, moving on to the mechanism of this rising stem valve. As you open the valve, the stem actually lifts up, giving that visible indication of the valve's position. It's a simple but very effective design for situations where knowing whether a valve is open or closed is critical. On the other hand, we have the non-rising stem valve, which is often used in different applications. For example, in buried systems or areas with limited space, this type is more practical. Since the stem remains stationary during operation, it doesn't rise when you open or close the valve. Instead, the internal threads move the gate internally to control flow. Understanding these different styles helps us choose the right valve for each application, ensuring safety, efficiency, and ease of operation. When we notice a packing leak in this type of valve, it usually indicates that something's gone wrong internally. Specifically, the internal bellows might have ruptured, or perhaps the weld on the bellows assembly has cracked. This is a critical point because such failures compromise the valve's ability to maintain a hermetic seal. That's why, in most cases, it's recommended to replace the entire bonnet assembly once the bellows fails. Doing so helps ensure that the valve continues to perform reliably and maintains that essential hermetic seal. Now, these valves are used in applications where zero leakage of the working fluid into the environment is absolutely crucial. Think about hazardous materials or environmentally sensitive substances. These valves prevent any leaks that could cause harm or contamination. Their primary function is to contain the working fluid completely, which is where the bellows come into play. Speaking of the bellows, they are a specialized modification of standard linear valves like gate or globe valves. The key difference is that they incorporate a flexible metallic element, the bellows, that creates a hermetic seal around the stem. This design ensures that the fluid stays contained, no matter what, providing a zero leakage solution. This specialized design makes bellows seal valves ideal for critical applications where leaks are simply not an option. They are engineered specifically to address the need for absolute containment, which is why they're often called zero leakage solutions. So, understanding these key points highlights how vital proper maintenance and the right valve selection are in safeguarding both the environment and process integrity. Now, let's take a closer look at a specialized type of ball valve that you'll often find at the water main on a saddle. This component acts as the initial shutoff connection for a customer's water service line. Its main purpose is to isolate that service from the high-pressure main, allowing for safe maintenance or emergency shutoff. This particular valve is called a corporation stop, or corp stop for short. You'll typically see these on customer water meters and small backflow assemblies. It's important to note that corp stops are designed to be either fully open or fully closed. They're not meant for throttling or fine regulation. When the valve is rotated 90 degrees, the solid side of the ball inside it blocks the flow completely, which we call the closed position. Conversely, when the ball is aligned with the pipe, the bore through the ball allows full flow with minimal restriction. That's the open position. Ball valves like these are quick-acting rotary valves, meaning they control flow by turning a spherical ball with a bore through its center. A simple 90-degree turn is enough to fully open or close the valve, making them very efficient for isolation purposes. Connecting this to the overall theme, understanding how these valves work is crucial for proper water system operation and maintenance. They provide a reliable, easy way to control water flow, especially at critical connection points like the water main and customer service lines. When operating large butterfly valves, you might find that a valve operating machine is necessary because of the high number of turns needed to fully open or close the valve. This ensures smooth and safe operation, especially in larger systems. It's important to install the valve in the closed position initially to prevent damage to the laminated seal inside the disc. Proper installation helps maintain the integrity of the seal and prolongs the valve's lifespan. Often, you'll see these valves installed with a bypass valve, usually a gate valve. The purpose of this bypass is to equalize pressure and prevent water hammer when opening or closing the main valve. It's a simple but effective way to manage pressure surges in the system. Interestingly, butterfly valves can be used not only for isolation, but also for throttling or flow regulation. Their design allows the disc to be positioned in a way that makes flow control possible, giving them a unique advantage over gate valves, which are typically only used for on-off functions. These valves are generally large and are found on major transmission lines and throughout treatment plants. They feature a movable internal disc that's roughly the same size as the pipe bore. A simple quarter-turn rotation of the disc opens or closes the valve quickly and efficiently. So, in summary, butterfly valves are versatile, large rotary valves that offer both control and isolation capabilities, with specific installation and operation considerations to ensure optimal performance. When installing globe valves, it's generally best to position them with the inlet below the valve seat. This orientation helps ensure they operate correctly and also prevents premature wear of the internal components, which is crucial for maintaining their longevity. Now, while you might not see globe valves very often in typical distribution systems, they are quite common in treatment plants. That's because these settings often require precise flow control, whether it's for chemical dosing, filtration rates, or optimizing various processes. Speaking of design, one of the key features of globe valves is the significant pressure drop they introduce. But this is actually a good thing because it allows for excellent throttling and flow modulation. The tortuous flow path inside the valve provides superior control over flow rates, especially when compared to gate valves, which don't offer the same level of regulation. Let's talk about what makes them unique. Unlike gate valves, globe valves are mainly used for flow regulation. Think of them like a faucet. They operate with a disc that moves perpendicular to the flow. The flow itself is redirected through a tortuous path around a seat, which helps in precisely controlling the flow rate. In summary, globe valves are all about precision flow regulation. Their design allows for tight control, making them ideal where flow accuracy is essential, and that's why they're a vital component in many specialized systems. Let's take a closer look at some specialized rotary valves that are quite essential in certain piping situations. First, quarter-turn rotary valves are designed to manage flow in tight piping configurations. They are especially useful when space is limited because their 90-degree angle design allows for easy installation in confined areas where traditional straight-through valves simply won't fit. You'll often see these used on water service lines, where their compact design makes installation and maintenance much easier. Moving on to angle stop valves, these feature a long, tapered, needle-like point on the end of the valve stem that acts like a disc. This design lets you make very fine adjustments to the flow rate by gradually increasing or decreasing the size of the opening. Because of this precision, they're often used for fine-tuning fluid flow or as components within more complex valve systems, such as reducing valves. Next, needle valves use a cylindrical or tapered plug that rotates to control flow. Think of the plug as a gate that aligns with the flow path when open, allowing fluid to pass through. When you rotate it a quarter turn, it blocks the flow completely. These valves are widely used in low-pressure sanitary and industrial applications, including petroleum pipelines and chemical processing, because they can also regulate the flow of liquids containing suspended solids, like slurries. Finally, plug valves are another type of rotary valve, where a cylindrical plug with a passage through it rotates inside the valve body. When aligned with the flow, the fluid passes through. When rotated 90 degrees, it blocks the flow. These are versatile and reliable, especially suited for applications requiring quick opening and closing, and are commonly used in various industrial processes. All these valves exemplify how specialized designs can optimize flow control in different settings, fitting into the overall theme of selecting the right valve for the right application to ensure safety, efficiency, and ease of maintenance. Let's talk about the role of air release and vacuum valves in pipeline systems. First, allowing entrained air, which are small pockets of air trapped in the flow, to escape while a line is under pressure is crucial. This process increases the flow capacity and helps reduce head loss, making the system more efficient. When the pipeline is being filled, it's important to allow large amounts of air to escape quickly. This ensures a smooth and efficient startup, preventing any delays or issues. On the other hand, when you're draining a pipeline, permitting air to enter is just as vital. This prevents the formation of a vacuum or even pipeline implosion, which could cause the pipe to collapse or become contaminated. Now, these air and vacuum management devices are typically equipped with internal floats that respond to water levels and pressure. They automatically open to release or admit air as needed, maintaining proper pressure balance. You'll want to install these valves at high points in the pipeline, places where air pockets tend to gather. It's also essential that these valves are located where they won't be flooded, to prevent contamination and ensure they function correctly. Overall, Properly managing air and vacuum in your pipeline not only helps in preventing damage, but also ensures safe and efficient operation. It is really important to understand that a simple check valve is not the same as a backflow preventer, also known as a backflow prevention assembly. A backflow prevention assembly is a more complex, legally required device. It typically consists of two independent mechanical check valves along with two shutoff valves. And, to ensure it's functioning properly, it must be checked annually by a certified tester. Now, these assemblies are often installed on the discharge side of pumps. Their main role is to prevent backflow, which can cause serious damage to the pump itself. Some common types you might encounter include plain swing check valves, lever and spring swing checks, and rubber flapper swing checks. The primary purpose of check valves, in general, is to allow flow in only one direction. They're designed as one-way valves, using a hinged flap, a disc, or a ball that opens when fluid flows forward. When the flow stops or reverses, gravity or the reverse flow itself causes the valve to shut, preventing any unwanted backflow. In essence, check valves serve as a critical line of defense, protecting equipment and maintaining the integrity of the system. They're simple but vital devices that ensure flow remains unidirectional, supporting the overall efficiency and safety of the system. Now, let's take a closer look at pressure control valves and their crucial role in water systems. These valves are designed to automatically modulate flow, helping us manage pressure within pipelines and systems effectively. Each type of valve serves a specific function, which is vital for maintaining system safety and efficiency. First, we have the float valve, which ensures accurate and repeatable level control in tanks by setting high and low points. This helps prevent overflows and dry running. Next, the surge anticipator valve protects our pumping equipment and pipelines from sudden changes in flow velocity that could cause damage. Then, there's the altitude valve, which controls the high water level in elevated tanks or standpipes, preventing overflows that could lead to system issues. The pressure relief valve is another critical component. It releases excess pressure that might develop suddenly due to changes in water velocity, acting like a safety valve. We also have the pressure-sustaining valve, which maintains a minimum system pressure regardless of demand fluctuations, ensuring consistent operation. Finally, the pressure-reducing valve, or PRV, delivers water from a high-pressure system to a lower-pressure one, maintaining a set maximum outlet pressure to protect downstream equipment. Together, these valves form a comprehensive pressure management system, essential for operational safety, system longevity, and overall efficiency. They work in harmony to keep our water systems running smoothly under varying conditions. Now, let's talk about maintaining consistent pressure in variable demand conditions. This is really important because water demand can fluctuate throughout the day, and we need to ensure that pressure remains stable. One key aspect is protecting low-pressure zones from high-pressure sources, which helps prevent damage and ensures safety throughout the system. Another critical point is reducing the pressure from transmission mains down to the levels suitable for distribution. This step is vital for efficient operation and to prevent stress on the infrastructure. When we look at applications, pressure-reducing valves, or PRVs, play a central role. They work by throttling flow in response to downstream pressure changes. Typically, these are globe valve designs with a spring-loaded diaphragm that automatically adjusts the opening based on the outlet pressure. This automatic response helps maintain the desired pressure downstream. The core mechanism involves delivering water from a high-pressure system to a lower-pressure one while keeping the outlet pressure within a preset maximum. This function is essential because it protects downstream infrastructure from overpressurization and ensures that customers receive a consistent service pressure. In summary, the primary function of these pressure-reducing valves is to regulate pressure effectively, ensuring system stability and safety across varying demand conditions. They are a vital component in maintaining the overall health and efficiency of our water distribution system. Now, let's take a closer look at the surge anticipator valve. This valve opens initially when a low-pressure wave occurs, which typically happens just before a high-pressure surge. It then closes slowly to prevent any subsequent surges, offering critical protection for expensive infrastructure. Its main role is to safeguard pipelines and pumping systems from the damaging effects of sudden pressure changes. Next, we have the altitude valve. Its purpose is to ensure efficient storage management by controlling the water level in elevated tanks or standpipes. It automatically closes when the tank is full and opens when the pressure on the inlet side is less than that on the tank side. This automatic operation helps maintain a constant water level and prevents overflows, ultimately reducing water waste. Moving on, the pressure-sustaining valve plays a vital role in maintaining consistent pressure upstream. It automatically throttles to keep a minimum upstream pressure setpoint, protecting customers from pressure drops during peak demand or fluctuations. This is especially important in supplying high-altitude areas or critical zones where reliable pressure is essential. In summary, these specialized pressure control valves, surge anticipators, altitude valves, and pressure-sustaining valves are crucial for protecting infrastructure, ensuring efficient water storage, and maintaining consistent pressure throughout the system. They work together to enhance the reliability and safety of the entire water distribution network. Let's talk about how we can protect our system from water hammer. One effective solution is installing a pulsation dampener or surge tank. These devices help absorb the force of moving water and cushion pressure spikes, which can otherwise cause damage. Next, we have dampeners, specifically air and vacuum relief valves, usually installed downstream of a closing valve. Their job is to allow air to enter the line when needed, preventing the formation of a damaging vacuum that could harm the system. When operating valves, especially gate valves or any control valves, always take your time. Gradually opening and closing them helps prevent sudden changes in water velocity, which can lead to pressure surges. Now, speaking of pressure spikes, they can be quite severe, up to 5 times the normal system pressure. Such spikes can blow out diaphragms, seals, gaskets, or even destroy meters. In the worst cases, they can cause pipe ruptures and catastrophic failures, so it's crucial to control these surges carefully. Finally, let's understand what water hammer actually is. It's a pressure wave or surge caused by the kinetic energy of water when it's forced to stop or change direction suddenly. The primary culprits are quick-closing valves, like fire hydrants or ball valves, and pump starts or stops. Recognizing these causes helps us take preventive measures to keep our systems safe and reliable. Let's talk about the importance of proper valve stem care. A valve stem that's improperly lubricated or damaged, even something as small as a bend, can make the valve really difficult to operate. That's why regular inspection and proper lubrication are so essential. These simple steps help maintain the valve's operability and, importantly, extend its service life. Moving on to storage, when storing new gate valves, always keep the gate in the open position. Cover them up to protect the rubber seals and internal parts from UV radiation and debris. Sunlight can degrade those rubber components over time, which can compromise the entire valve's integrity. And finally, I want to emphasize the importance of annual exercising for mainline valves, especially gate valves. Fully opening and closing them once a year helps prevent rust and corrosion from building up, which can make valves inoperable when you need them most. It also allows us to check for any potential issues early, ensuring everything operates smoothly and reliably when it matters. Let's take a closer look at some of the key types of valves and their applications. First, we have the hermetic seal bellow seal valve, which requires a full replacement if it fails. Its main advantage is that it provides a hermetic, airtight seal, preventing leaks. It's essential in systems requiring zero leakage, and it must be installed above flood level to prevent contamination or flooding issues. Next is the air relief valve, which plays a critical role in air management within the system. It helps prevent vacuum formation and airlocks, but it requires regular maintenance to ensure proper operation. Automatic pressure control, often through a PRV, helps to reduce pressure safely and efficiently. Remember, a pressure relief valve isn't a backflow preventer, but automatically prevents backflow by releasing excess pressure. Moving on, the check valve protects the pump by allowing flow in only one direction. It's on-off only, with no throttling capability. Its quarter-turn operation makes it quick and easy to operate. The ball valve offers quick shutoff capabilities and is ideal for high-pressure drops. It has excellent throttling capabilities, making it versatile for various flow control needs. The globe valve is designed for precise flow control, but for large sizes, a bypass might be necessary. It can throttle flow and isolate sections of the system when needed. The butterfly valve is used for large line control, but it's not suitable for throttling applications because it doesn't provide precise control. When fully open, it offers minimal pressure drop, which is advantageous in certain scenarios. The gate valve is primarily used for main line isolation. It's straightforward and reliable, but has limitations in terms of throttling capabilities. Understanding these key differences helps us choose the right valve for each specific application. Selecting the appropriate valve is critical for ensuring system performance, safety, and longevity. This matrix serves as a practical guide, aligning valve functions with system requirements to make well-informed decisions. Now, let's talk about some common valve problems and their solutions. First, pressure control failure can often be addressed by using the appropriate valve type for the specific application, ensuring that operations are slow and controlled, and by installing strainers to prevent debris from causing issues. Next, damaged seating surfaces usually occur due to worn packing, a damaged stem, improper installation, or over-tightening. To fix this, we should replace the packing, inspect the stem for any damage, and make sure the installation torque is correct. Leaking around the stem is another common problem, often caused by corrosion buildup, a damaged stem, lack of lubrication, or debris in the mechanism. A good approach here is to establish a regular exercising program for the valve, apply proper lubrication, inspect the stem regularly, and remove any debris. Finally, if the valve won't open or close, it might be due to issues like stuck or broken components, corrosion, or debris blocking the mechanism. The key is to identify the root cause, whether it's a mechanical fault, corrosion, or debris, and address it accordingly. Overall, understanding these problems and applying the right solutions is essential for maintaining reliable valve operation and ensuring the integrity of the entire system. Let's go over some critical safety notes before we start. Always assume a valve may be under pressure, even if it looks like it isn't. Never stand directly over a valve when you're operating it, because water hammer can cause violent movement of the valve or even damage components. This can lead to serious injuries, so safety always comes first. Once you've operated the valve, it's important to monitor the system for any pressure or flow anomalies. Keep an eye out for unexpected changes that might indicate a problem. Be sure to update the valve exercise records to keep our system documentation current. Also, make sure the valve box covers are properly replaced to prevent debris or unauthorized access. If you notice any operational issues, report them immediately. Document the valve's current position and condition so we have a clear record. Remember, after operating the valve, be aware of pressure differentials that might still be present. Never force a stuck valve. Forcing it can cause damage or leaks. Instead, monitor for unusual sounds or resistance, which could signal a problem. For gate valves, counting the number of turns can help us track their position accurately. Always operate valves slowly to prevent water hammer. Rapid movements can cause pressure surges. During operation, verify that bypass valves, especially for butterfly valves, are functioning properly. If needed, notify affected customers to keep them informed. Ensure you have the proper tools ready before starting. Check for visible damage or leaks on the valves or surrounding equipment. Confirm you're wearing the correct personal protective equipment, or PPE, to stay safe. Also, Verify the valve identification and location to ensure you're working on the right component. Finally, always follow your pre-operation checklist and safety protocols for valve operations. These steps are vital for safe and effective system management. By sticking to these guidelines, we help protect ourselves and ensure the reliability of our water system. Understanding valve technology thoroughly is essential for ensuring our water systems run reliably. When we install air valves at high points, check valves on pumps, and pressure control valves where needed, we're taking proactive steps to protect the infrastructure investments we've made. Remember, prevention is always more cost-effective than repairs down the line. Regular system protection includes annual exercising of valves, which helps prevent failure, and proper lubrication and storage to safeguard the components. It's also vital to document all maintenance activities so we can track performance and identify potential issues early. Maintaining our system regularly is crucial because water hammer, for example, can create pressure spikes up to 5 times the normal operating pressure. To avoid damage, always operate valves slowly and make sure you're using the proper safety equipment. Safety should always come first. Knowing your valves is fundamental. Each type has specific applications and limitations. Gate valves are great for isolation. Globe valves are used for throttling. Butterfly valves handle both functions, and specialized valves provide automatic control. Understanding these differences helps us select the right valve for each situation, ensuring safe and efficient operation. Overall, mastering valve knowledge is key to maintaining a safe, reliable, and efficient water distribution and treatment system. This guide provides the foundation for making informed decisions about valve selection, operation, and maintenance. So let's keep these principles in mind as we work to protect and optimize our water systems.